The Lexical Tokenizer subsystem provides character-level stream decomposition and pattern matching across input buffers. This module operates on a stateless basis, processing sequential character arrays without maintaining context between invocations. The primary entry point accepts a buffer pointer, buffer length, and an output token array reference. Return values indicate the total number of tokens produced or an error code if buffer overflow occurs during tokenization. Token classification proceeds through a deterministic finite automaton that recognizes 6 primary categories: whitespace, alphanumeric sequences, punctuation marks, numeric literals, operator symbols, and delimiter characters. Each character input advances the internal state machine. When a character cannot be appended to the current token type, the existing token is emitted and a new token begins. The automaton reset occurs at buffer boundaries or upon explicit flush requests. Whitespace handling follows the Unicode standard definition for space, tab, newline, and carriage return characters. These characters trigger immediate token emission if a non-whitespace token is in progress. Consecutive whitespace characters collapse into a single token with a length field indicating the total span. The whitespace token type flag allows callers to filter these characters during post-processing if required. Alphanumeric token boundaries are defined by the first character being alphabetic or underscore. Subsequent characters may be alphanumeric or underscore. This produces identifier-style tokens compatible with standard lexical conventions. The tokenizer does not distinguish between reserved keywords and user-defined identifiers. That classification occurs in subsequent compilation phases. Token length is limited to a maximum of 256 characters per constraint specification. Numeric literal recognition begins with a digit character. Both decimal and hexadecimal formats are supported. Decimal sequences continue while digits are encountered. Hexadecimal format detection occurs when a 0 prefix is followed by an lowercase x character. Subsequent characters must be hex digits 0 through F or an error flag is set. Floating point notation via decimal point is not supported in the current implementation. Operator symbols are recognized as single character tokens from a predefined set: plus, minus, asterisk, /, ampersand, pipe, caret, tilde, exclamation, question mark, and equals. These characters do not combine into multi-character operators within the tokenizer. Multi-character operator assembly occurs at the parser level. Each operator character terminates any preceding token and forms its own single character token. Delimiter characters include parentheses, square brackets, curly braces, comma, semicolon, and period. These characters immediately terminate preceding tokens and are emitted as individual tokens. No lookahead is performed for delimiter characters. The tokenizer maintains no context regarding nesting depth or bracket matching. These concerns are deferred to later parsing stages. Delimiter tokens have zero-length content buffers. The output token array is a fixed-size structure initialized at module load time. The default capacity is 4096 tokens per invocation. Each token entry contains a type enumeration, a start-off set within the input buffer, a length field in bytes, and a line number annotation. The line number is computed during tokenization by counting new line characters from the buffer start. Overflow conditions return error code 0x03 when capacity is exceeded. Error handling in the tokenization process follows a fail-fast model. Invalid character sequences, such as hex digits appearing without a preceding 0x prefix in numeric context, trigger an error flag on the current token. Processing continues to the next character boundary. The error token is still emitted to the output array, but marked with an error classification. Caller code may choose to terminate parsing or continue based on the error flag. Buffer boundary handling occurs when the input buffer terminates. Any in-progress token is immediately emitted. No padding or null termination is performed on partial tokens. If a long token spans multiple buffer loads, the caller must reassemble token fragments using the offset and length fields. The module provides no automatic buffer management. External code controls buffer lifecycle and refilling. Memory requirements for the tokenizer are minimal and bounded. The internal state machine occupies 16 bytes. The output token array requires 16 bytes per token capacity slot, resulting in 65 kilobytes for the default 4096 token capacity. No dynamic allocation occurs during tokenization. All memory is pre-allocated at module initialization. The module is therefore suitable for real-time and embedded contexts. Performance characteristics are linear with respect to input buffer length. The time complexity is O of n, where n is the number of input characters. No backtracking or look-ahead is required beyond the immediate next character. Throughput testing indicates processing rates of approximately 100 megabytes per second on contemporary processors. Tokenization latency for typical program files is sub-millisecond. Integration with the parser component occurs through a callback registration mechanism. The parser may register a function pointer to be invoked upon token emission. This allows streaming token processing without materializing the entire token array. Buffering remains necessary for tokens that require look-ahead, but the callback model supports single-pass compilation when the downstream grammar permits. Configuration parameters are established at module initialization through a configuration structure. These include the maximum token length, output array capacity, whether whitespace tokens are emitted or suppressed, and the character encoding mode. The encoding mode selection determines whether input is interpreted as ASCII, UTF-8, or binary. UTF-8 mode treats multi-byte sequences as single character units within tokens. State reset and reinitialization are triggered through the flush operation. This clears the internal state machine and prepares for processing a new input stream. The flush operation does not clear the output token array. Callers must copy token data before flushing if retention is required. Flushing an already flushed tokenizer is a no operation and incurs no performance penalty. Diagnostic logging capabilities are available through an optional tracing mode activated at compile time. When enabled, each state transition and token emission is written to a log buffer. The logging overhead is approximately 3% when active. Log buffers are ring buffers with fixed capacity of 16 kilobytes. Circular overriding occurs when capacity is exceeded. Diagnostic logging is disabled by default in production builds.